Okay, so today we are going to start with our unsupervised learning algorithms. So far all the algorithms that we have covered is supervised learning algorithms only, right? So I hope you remember the difference between supervised and unsupervised. Yes, Upendra, can you quickly summarize what is unsupervised? Very quickly, anyone?
Unsupervised, as in we will not have any labels, so we will cluster the data and find out the patterns in the data.
Very good. In unsupervised, we have variables, we don't have a y. There is no dependent variable in unsupervised learning, right? We only have our features. So that's why the objective of any unsupervised algorithm is not doing any predictions, rather it is mostly clustering or segmenting the data into various similar groups. So mostly we'll be looking at finding similarities around data, grouping the similar data together. Right? So one such algorithm, one such approach in unsupervised learning is known as clustering. So today we are going to see that. Okay. So we are going to create a recommendation system for movies in this case. Right. So talk about Netflix. So Netflix is again an online DVD rental and streaming video service. So now it's mostly streaming video only. And it has more than 40 million subscribers worldwide. It's pretty old data, so now it will be even much more. And $3.6 billion in revenues. Right. Now the key aspect is being able to offer customers accurate movie recommendations based on the customer's own preferences and viewing history. Right. So recommendation is like very at the core of all this. Websites like Netflix and IMDb, Amazon, etc. So now Netflix actually ran a data science competition between 2006 to 2009, asking the public to submit algorithms to predict user ratings for movies. So they wanted algorithms that can predict user ratings for movies. Okay. And they had this huge set of data. They had almost 100 million ratings on the trained data and 3 million ratings on the test data. So these were provided to the participants. And they were offered a grand prize of 1 million USD to the team who could beat Netflix's own algorithm, Cinemax, by more than 10% measured in RMS. Now, this was not a totally unsupervised, it was a supervised learning problem, that's why we have RMSE here. Okay. But on the similar lines, we are going to, on the similar data, we are going to do unsupervised learning. Let's see that. So these were few of the contest rules during 2006 to 2009. So it said that if the grant prize was not reached, means if you're not able to beat the 10% mark, but if you keep on, if you can improve by 1% every year, you are still eligible for a $50,000 USD progressive prize. Okay, provided you are beating 1% every year. And the team should submit code and description of the algorithm to be awarded any prizes. That's fine. And if any team met the 10% improvement goal, last call would be issued and 30 days would remain for all teams to submit their best algorithm. So these are the few initial results. So the contest went live on October 2nd, 2006. And by October 8th, just a week after that, a team submitted an algorithm that beat Cinemax. And by October 15th, there were 3 teams that could beat Cinemax. And one of this was actually beating Cinemax by more than 1%, thus qualifying for the progress prize of 50,000 USD. Okay. Now by June 2007, over 20,000 teams had registered for the work from 150 countries. The 2007 Progress Prize went to the team Belcor with an 8.43% improvement on Cinematch. So this prize went to Belcor, it was from Bell Labs. So which an 8.43% improvement on Cinematch. And the following year, several teams from across the world joined forces. Okay. The 2008 Progress Prize went to Team Belcor, which contained researchers from the original Belcor team and as well as from the team Big Cures. Now, what these teams started doing was they started grouping with each other. You know, so that to create some kind of ensemble. Is my model is working on some good on some observations. Your model might be working on some other observations. If you group both of if we join together, then of course we can have a better predicted model. So it's kind of creating your own ensembles. Okay. So the Belcor and the Big Cures merged together and they won the Progress Prize for 2008. So now we have close to 9.5% improvement on Cinematch. And any 1% improvement means you are going to cross the 10% mark. So you are going to be eligible for the $1 million. Okay. On June 26, 2009, the team Belcor's Pragmatic Cure submitted a 10.05 improvement over Cinematch. See this now. 10.05% improvement on Cinematch. Okay. So now there were 30 days for other teams to submit their algorithms before the contest closed. And these 30 days are filled with intense competition and even more progress. But before revealing what happened, let's investigate how we could try to predict our own user ratings. So now we are going to discuss how these recommendation systems work. Recommendation systems. Okay. Predicting the best user ratings. It says Netflix was willing to pay over $1 million for the best user rating algorithm. Right? Which shows how critical the recommendation system was to their business. Now, what data could be used to predict user ratings? So now it says every movie in the Netflix database has a ranking from all users who have ranked that movie. Okay. So we have the ratings for all the users who have ranked that movie. And we also, that is one thing, that is the rating from other users. And we also know facts about the movies, that is actor, director, genre, classifications, year release, etc. Okay. So other than that, we also know the details about the movie, like who are the actors, director, genre, etc., year release, etc. So this data also can be used. Okay. So now one approach of doing recommendation is using other users' ratings. Okay. Now look at this example. So there are four movies: Men in Black, Apollo 13, Top Gun, and Terminator, and these are four friends: Amy, Bob, Carl, and Dan. Right? And these are the ratings they have given to these movies. So Amy has rated Men in Black 5, Apollo 13 4, Top Gun 5, Terminator 4. Bob has rated Men in Black 3, Top Gun 2, Terminator 5. Carl has rated Apollo 13 5, 4, 4, Dan 4, 2, etc. Now what I want you to tell me is out of these four users, which two users do you think have similar taste? Which two users have similar taste? Tell me this.
No. Carl and Amy.
Carl and Amy. Why?
Because they've watched the same movie and they've also given the similar rating to those movies.
Right. So if you see here, Carl and Amy have similar tastes, right? So Top Gun 5, 4, Terminator 4 and 4, right? So now what I can do on the basis of that, I can, since Amy and Carl have similar taste and Amy have watched Men in Black, so what I could do is I can also recommend uh, Carl to watch Men in Black, right? So what I can do, consider suggesting Carl that he watches Men in Black since Amy rated it highly and Carl and Amy seem to have similar preferences, right? So this technique is known as collaborative filtering. Clear? So now this approach is known as user to user, meaning I am comparing two users and then I am comparing their taste. So I'm not bothered about what kind of movie is that or like what is the content of the movie. I'm only bothered about the users, right? So if X likes X and Y have similar taste, if X likes one thing, so Y should also like that, right? So this is known as collaborative filtering. Collaborative filtering. Okay. Now other approach is item to item. Okay. So now Amy likes Men in Black. So Men in Black was directed by Barry Sonnenfeld, classified in the genres of action, adventure, sci-fi, and comedy. And it stars actors Will Smith. Right? So what I can do, I can recommend Amy any movie from these categories, like any movie which is directed by Barry Sonnenfeld, or any movie in the similar genre like Jurassic Park, or any movie which has same actor Will Smith, that is Hitch. So this is a pretty straightforward approach. This is known as content filtering. So now here I am comparing the items. We are comparing Men in Black with the features of Men in Black with other movie features, right? So here we don't have anything to do with the users. So this is known as content filtering. Okay. Now both approaches have their own strengths and weaknesses. So collaborative filtering, the benefit of collaborative filtering is like I can accurately suggest the complex items without actually understanding the nature of the items. So here I'm since I'm doing it user to user, I'm not bothered about like what all qualifies in a particular movie, like what all features are there in a movie, right? I'm just focusing on the users. The problem is it requires a lot of data about the user to make accurate recommendations. So I make sure that but now I want to make sure that I'm able to identify the unique taste of that customer. So I cannot do that just by seeing his ratings or reviews on one or two movies. That will be a biased approach. So I need to require large amount of data to make accurate recommendations, right? So since it is data intensive, so millions of items, so needs lot of computing power. Another issue is like the cold start problem. So suppose if I start a website like this, movie website or maybe an e-commerce website. So unless until I have very big customer base, my models will not be accurate, right? So but if I don't have much lot of customers, then how I'm going to make recommendations? Getting this? On the other hand, content filtering is very straightforward. It requires a very little data to get started, but of course it is very limited in scope. So now if you see here, even just by managing a single movie, I can actually recommend something to Amy on the basis of these three features, right? But then we can see we are restricting ourselves. We are restricting to these three classes only. Amy might also like some romantic movies, but since we have only chosen one Men in Black, so those romantic movies might not be recommended to Amy, okay? So requires very little data to get started, can be limited in scope. And then we have this hybrid recommendation systems also, which is a mix of both collaborative and content. So now it says, for example, consider a collaborative filtering approach where we determine that Amy and Carl have similar preferences, right? So from collaborative, we find out that Amy and Carl have similar preferences. That's step one. And now what we can do, we could then do content filtering where we would find that Terminator, which both Amy and Carl liked, is classified in the same set of genres as Starship Troopers, right? So Amy and Carl have watched Terminator, and Amy and Carl have similar likes. Now from content filtering, I know that Terminator and Starship Troopers are same. So now if I mix both collaborative and content, I can recommend Starship Troopers to both Amy and Carl, even though none of them have watched it before. Clear? Any doubts, anyone? Yes, please. Isha, Upendra. Okay. Now answer this quickly. We have 1 minute to do so. Hello. Yeah, what is the answer for this?
Collaborative filtering.
So this one is simply collaborative filtering. Very good. Only two answers. How about others? Isha, Upendra, is it clear or not?
Yeah, Himanshu, it's fine.
Yeah, Himanshu, I mean, it is not clear.
Not clear? Okay.
Yeah,
See this. So it says let's consider recommendation system on Amazon.com, an online retail site, right? So if Amazon constructs a recommendation system for books and would like to use the same exact algorithm for shoes, what type would it have to be? Okay. So now I have to use the algorithm that I created for books and use it for shoes. So of course it cannot be content filtering because the content of books and content of shoes will be totally different. Content of books will be author, genre, publisher, editor, etc. Content of shoes will be brand, type of shoe, size of shoe, color, design, etc. Right? So these will be the content. But what I can, so that I cannot do it. But what I can do is like I can say, okay, if two users have similar taste, if two users have bought similar kind of books, then I can recommend similar kind of shoes to these two, because I know that they both of them have similar tastes, right? So what I can do here is I can only do user to user only. I cannot do item to item filtering here. So that's why it will be collaborative filtering only. Is that clear? Yeah, Isha?
Yes, Himanshu.
Okay, do one more now. Do this. Yeah, what should we answer for this one? Good Isha, good Mohit, good Aman, very good Nisha. So this is of course example of content filtering, right? Okay. So now let's get into what is clustering. Now we're going to use the data from this website, movielens.org. It's an excellent website for data on movies. It's a movie recommendation website run by the group Lens Research at the University of Minnesota. And they collect user preferences about movies and do collaborative filtering to make recommendations. Okay, and we will use their movie database to do content filtering using a technique called clustering. So I'm going to use the movie database to apply clustering. Okay, so now the movie lens data in this movie lens data set, we have different genres, 19 different genres: unknown, comedy, film noir, sci-fi, action, crime, horror, thriller, adventure, and so on. Right, and usually each movie is classified in 3 to 4 genres. Say for example, Jurassic Park might be sci-fi, action, adventure. Right. Man in Black again will be similar: sci-fi, action, adventure, maybe thriller also. So each movie will belong to 4 classes or 4 categories, genres, right? So now the question is, can we systematically find group of movies with similar set of genres? So I have to find out movies with similar set of genres. So how should I do this? So now try to visualize this. So there might be some movies which have exactly same genres, right? So of course they will be like very similar to each other. They will be the best match. But then there might be some movies which will be somewhat similar, not exactly but somewhat similar. And then there will be movies which are totally different in terms of genre, etc. Right? So first of all, why clustering? So clustering is an unsupervised learning technique. The goal is to segment the data into similar groups instead of predictions. Okay. So can also cluster data into similar groups and then build a predictive model for each group. So that's one thing we can do over clustering also, that we can build up a predictive model on the basis of clustering. Okay. Now there are many different algorithms for clustering and they differ in what makes a cluster and how do we find them. So now we are going to cover 2 algorithms. One is hierarchical clustering and another is k-means clustering. So these are two are the very popular form of clustering algorithms. Okay. Okay, answer this now very quickly. Very quickly. Okay, good. So you can see the first, second options are the first one and two are the correct option. Dividing search results on Google into categories based on the topic and grouping player into different types of basketball players that make it to the NBA. Well, the third one is again a supervised learning problem. Okay, yeah. So now we have computing distances. So before we get into this, let me go back to the example again. Okay. Now in this example, you said that Amy and Carl have similar preferences or similar taste. So how did you concluded that? And can you quantify this? Yes, please. You can use the mic to speak out. It's difficult to look at the chats. Yes, Isha. How can you quantify that Amy and Carl have similar tastes?
Yeah, Himanshu. I mean, we have just seen the pattern. I mean, how we can quantify.
See, so you said that. So if you
Like,
see here, Apollo 13 and Carl and Amy, 4 and 5 are close to each other, right? Top Gun is
yeah.
5 and 4. So if you can see the difference between the two, right?
Okay.
Means how far or how close they are. So that's why we compute the distances. I'll come back to this. Computing the distances. Right? So now why we are computing distances? So I think it should be intuitive. So now if you see here, just a second. Yes. So now if I could somehow represent this movie in my Cartesian space, right? What I can do is I can find the distances between the two. Let's say for example, one point is some, let's say this one, right? And maybe one point is here, or one point is somewhere here. So those movies which are closer to each other should be similar. Getting it or not? Okay. So now how do I find the distances? So we need to define distance between 2 points, and the most popular way is of course the Euclidean distance, right? So what is Euclidean distance? So this is how we find the distance between any 2 points. Just a second, I'll just put the pen tablet. Yeah. Now suppose I have 2 points, right? One is x1, y1, and one is x2, y2. So do you know what is the distance between these 2 points? High school coordinate geometry? Yes, Janu, Upendra, Isha.
Sir, it's x2 minus x1 plus y2 minus y1 का whole under root.
x2 minus x1 का whole square plus y2 minus y1 का whole
हाँ
square
whole
का whole
square
under.
plus और फिर under root.
Right. So this is your Euclidean distance. Okay, and that's the most popular technique of measuring the distance. There can be other way also, like one is d simply mode of x2 minus x1 plus mode of y2 minus y1. So this is known as Manhattan distance. Okay, but usually we use this one only, Euclidean distance. Okay. So now it was only 2D. If I have 3D also, three-dimensional space also, say for example x1, y1, z1 and x2, y2, z2. So then it will be, the Euclidean will have 3 brackets. It will become z2 minus z1 whole square also. Right? So now if I say you, okay, find the distance between Men in Black and let's say some other movie, maybe Jurassic Park. Right? So of course this will not sound very intuitive, like how can I find distance between two name of the movies Men in Black and Jurassic Park. Now I know that Men in Black is an action, adventure, sci-fi, etc. Similarly for Jurassic Park also I have certain genres. So what I have to do is like I have to find out some encoding techniques to make this data numeric. Meaning, now what I will do is, let's say I have a movie Toy Story. So now each movie will be represented by 19 features. What are those 19 features? These 19 genres that I have in the movie lens dataset. These 19. So these are the 19 features where to represent each movie. And for each feature, I will have only two possible values, 1 and 0. So now Toy Story belongs to animation, comedy, and children's. So in the column of animation, comedy, and children, I will put a 1. The rest all will be 0. So I'm doing a 0 1 encoding here, binary encoding. So if it is in a particular genre, it is 1, otherwise it is 0. Same thing will be the Batman Forever. It is in action, adventure, comedy, and crime. So for these 4 genres, I will have a 1, otherwise it will be for a 0. Now this order means a lot. So I cannot put 1 before, means I cannot change this order, right? It's because each column represents a particular genre. Now what I want you to do is find out the distance between this Toy Story and Batman Forever. Very quickly. Find out the distance between the two. Do this quickly. Yes, done. Very good, Ankit. Very good, Mohit. How about others? Isha, Upendra, quickly answer this. Very good, Isha. How about others? Nisha, Priyanka, Sandeep, Shruti. Quickly, please. Okay, any doubts? Do you want me to explain this or you can do it? Upendra?
Yeah, I can do it. I understood it. No.
Okay. So it will be simply root of 0 minus 0 whole square plus 0 minus 1 whole square for the second thing. Then again 0 minus 1 whole square plus, I think it is written over here. Yeah. Plus 1 minus 0 whole square and so on. So it will be root of 5. Right? So we compute the distances to find out the similarity between our observations or the movies in this case. So this was the Euclidean approach. Other approach will be Manhattan, which is sum of absolute values instead of squares. The one I described over here, which is also quite popular. But the other one is maximum coordinate distance. So we only consider measurement for which the data points deviate the most. So this is not commonly used, but it is one of the techniques. Okay, let it be. Yeah. So now there was two things. One is distance between the points, other is distance between the clusters. So what is this now? Okay. So let's say I have multiple movies. 1, 2, 3. I hope you can see my mouse. Right? And there are some here also, right? So let's say this is my one cluster, this is my another cluster, which has some movies. So now how do I find the distance between these two clusters, cluster 1 and cluster 2? So 2 points was easy, but now each cluster is a group of movies, a group of points. How do I find the distance between cluster 1 and cluster 2? Okay. So again, there are multiple possibilities. One is known as the minimum distance. So what I do is, now suppose I have two cluster of movies, one is yellow and one is red. So minimum distance is the minimum distance between the points. Distance between the cluster is the distance between points which are the closest. So here these 2 points are the closest. So this distance is my distance between the clusters. There is no perfect way of doing it. There are multiple ways of doing it. That's it. Or you can simply go with the maximum distance. These 2 points which are furthest from each other. Or we can, the most possible better one is centroid. We find the centroid. Okay. So we find the centroid and find the distance between those centroids. That's it. Okay. Now this is a very important slide, normalizing the data. So which we also seen in the end-to-end ML case also, but I'll reiterate it, especially in the case of clustering. It says distance is highly influenced by the scale of variables. So customary to normalize first. So what does that means? Now if you see here, distance is depends on the scale of x and y, right? So here all x, y, z are 1 and 0s only. So they are in similar scale. But suppose if I have one more feature, that is box office revenue for each movie, which will be maybe in millions of dollars or thousands of dollars. So let's say one movie is 10 and 100 millions. Other movie is 0 and 700 millions. Now if I find the distance between the two, I will have 1 minus 0 ka whole square plus 0 minus 0 square plus 700 minus 100 square, which will be huge number, right? Why huge number? Because of this. So you cannot do it like this. So what you have to do, you have to normalize first each of them first. Normalize means all the features should be in the same scale. Again, we have multiple possibilities. One is simply converting each and every variable to their corresponding z scores, x minus mu by sigma, or between 0 to 1. That is x minus x min upon x max minus x min. So if x is your at the maximum, this will be 1. If x is the minimum, this will be 0. And at every other possibility, they will be between 0 and 1 only. Clear? You can write this two down. So we have the standard scalar in our scikit-learn. I hope you remember that. That can take care of all those things. So scaling is not useful in as of in our data set, but it is most of the cases you have to normalize the data before applying any clustering algorithms. Clear? Okay, do this quick question very quickly. The movie The Godfather is in the genre of action, crime, and drama, and is defined in this vector. The movie Titanic is in the genres of action, drama, and romance, and is defined as this. What is the distance between Godfather and Titanic using Euclidean distance? Quickly. Very quickly. Yes, done. Okay, that's fine. I think most of you got it correctly. Nisha, that's not correct. You have to take the square root of that. So the answer is square root of 2. Right? Okay. Now let's get into hierarchical clustering. So now what is hierarchical clustering? Okay. So what we do is we start with each data point in its own cluster. Means suppose if I have 5 movies or 5 points, I'll make 5 clusters. 1, 2, 3, 4, 5. Okay. Next what I will do is, okay, I'll combine the two nearest clusters. But so how do I find the nearest clusters? First of all, I have to find the distance between each and every point. I have to find the pairwise distance between all those 5 points, right? So how many distances I have to compute in at this step to find out which 2 points are the closest? Yes, please. Better to use the audio. Okay, no one has responded. Yes, Isha, how many distances at this step?
For the first step, you're asking for, I mean,
Yeah,
suppose I have
I
to
want to find
find
pairwise distances between these 5 points, right?
pairwise.
Pairwise means just between red and blue, red and purple, blue and green, and so on.
Should be
That's
25.
pairwise distances. No, it won't be 20. It would be 5C2 or simply 10. So now I have 5 points A, B, C, D, E, right? A, B, C, D, E. So I have to find the distance of A with B, C, D, E. So 4 distances, right? Then when it is B, so B is A, B and B A will be same. So I have to find the distance between C, D and E. So 3 distances. C का D के साथ, D का only E के साथ. So 4, 3 plus 2 plus 1, that is 10. Or simply 5C2 if you are comfortable with permutation and combinations. 20 is not correct because AB and BA will be same. So it should be half of 20. Right, Shruti? Clear? So now this is the biggest problem with hierarchical clustering. That's computationally very expensive. For 5 points, I have to measure 10 distances. How about if I have 100 movies? How many distances? Yes, please.
Yes, quickly. How about 100 movies? It is 100 C2. So NC2 is n into n minus 1 by 2 factorial. If you don't know, that's totally fine. So it will be 100 into 99 upon 2. So that will be close to, how much is this? 99 into 50. 5000 minus 50. This 4950. Okay. Meaning almost close to 5000 distances I have to measure if I have just 100 movies. Even if I have 1000 movies, it will be huge. Right? So this step is usually the bottleneck in hierarchical clustering. When you see the data becomes large, this totally goes out of. It's not possible for a single RAM system to do, single CPU system to do that. Okay, but still, it's a good algorithm if the data is not that large. So out of measuring this, after measuring this 10 distance, I found out that green and yellow are the closest. So I'll make one cluster out of this. Okay. So the next step, what I have to do, I have to again combine the two nearest clusters. So now these two will be same clusters. So that's why these both are green now. There's no yellow. I combine them together into a single clusters. Now again, I have to measure the distance between all these points. But now I have 3 points and one cluster. So 3 points के बीच में I can use the Euclidean formula. But between a point and a cluster, I have to use the centroid. So first I will find the centroid of this. Right? And then I will find the distance here, here, and here as well. Okay. Clear? So now what will I get? I will get that, okay, this purple is also close to this. This is the closest. No. So now these three come to one cluster. Again repeating the same step. Now I have 2 points and one cluster. So one distance, two distance, and three distance I have to measure. Red, blue, blue, green, and red, green. So again the centroid, and then I will find the distances. But now you can see this will be closest, red and green. So this will be clubbed now. So now we don't have any single points. We have only two clusters. So अब मेरा एक red हो गया and one is green cluster. Right? And at the end I will combine all of them together, and then eventually I have a single cluster. Right? So we start with 5 points and eventually end up at a single cluster. Just give me a moment. Okay. Yeah. So now I started with 5 clusters and ended up with a single cluster. So now the question is, if we have to end up at even a single at a single cluster only, then what is the benefit? Means if I am clustering all the movies together in a single cluster, means I am recommending every movie to everyone. Getting it? So then it's of no use. So now what we have to do is, like, yes, we have to eventually last at a single cluster, but we need to have some way of breaking them also. So that's where we have this concept of dendrograms. So this is a dendrogram is a technique of representing hierarchical clustering. So this will not work in any other algorithm, it's only for hierarchical. At the bottom, which we have this 5 observations, 1, 2, 3, 4, 5. Okay, and the closest ones will be grouped earlier at the bottom. So initially 1 and 4 were the closest, so they were grouped together and we end up here. Then this cluster with 3 was the closest, so we grouped together and we were here. Parallelly 2 and 5 were the closest, so they got clubbed here. So now up to this stage, up to here, I have 2 clusters. One is 3, 1, 4, other is 2, 5. And now if these two are this much far from the each other, so if I move up to here, then here I will have a single cluster of 5 movies. Getting it? So now what we do is we cut this dendrogram. If I cut it from here, I'll have 2 clusters, 3, 1, 4 and 2, 5. Right? But if I cut it from here, I'll have only one cluster of 1 and 4. Rest all will be individuals only. So if I cut it from here, so I will have only one cluster of 1 and 4 and rest all will be individuals. Is that clear? See this. So look at one more example. Here I have 10 observations. If I cut it from this line, I will have 1, 2, 3, 4 clusters. So if I cut it from this line, I will have 1, 2 and 3 clusters. If I cut it from this line, I will have only 2 clusters. So as I go down, the number of clusters will increase, but the homogeneity will decrease. Yes, Isha, open the clear. So now if I want to divide 10 movies into three clusters, I can use this threshold. If I want two clusters, I want this threshold. Okay. उपेंद्र, ईशा, अंकित, श्रुति, समझ में आ रहा है ये? The use of dendrogram. Okay. So now this vertical distances tells you how similar or how heterogeneous these two clusters are. Meaning if I would travel a lot, yes, clear. Who's this? Aman, Ankit, Arvind, is it clear? So if we cut it from here, I will have 3 clusters. If I cut it from here, I will have 2 clusters. Okay, good. So this dendrogram helps you in identifying the number of clusters that you need to have. Okay. Now, here's the biggest question. How do I ensure that the clusters that I'm making are meaningful? How do I ensure that the clusters I'm making are meaningful? So one option is simply look at the statistics, mean, median, maximum, minimum, etc. for each character and each variable. Right? So look at the statistics, it is mean, median, mode, etc. So there should not be much difference between all of them. The min, max and medium or median or the mean should be close to each other, meaning the data is homogeneous. If they're very far, then the data is not homogeneous. Clear? This you can skip. Okay, answer this now very quickly. 30 seconds. Oh, I was on mute. Hello. So sorry. Yeah, answer is 212 and 1 only. We start with 212, end up with 1. So now we are going on a break of 10 minutes. After that, we'll start with the coding part. Okay. Good. So I'll resume at 11:10 now. Thank you.
This conference will now be recorded.
Okay, now let's start quickly. Okay. So you need to import NumPy, pandas. Now we are going to use SciPy for this. In SciPy.spatial import distance. And within that we import pdist. This is for your Euclidean distance. Yes, please. And then from scikit-learn.cluster import k-means as k-means and agglomerative clustering as h-cluster. Agglomerating clustering is the hierarchical clustering here. And for dendrogram, we'll be again using the scipy.cluster.hierarchy. I quickly ping you this. Yeah. So execute this. Yes, done. Now this is the file you have to read. So before reading it once, open it in your browser first. Just to understand the look and feel of the data. Can you see this? So this is not a typical CSV. What is the separator here? Yes, Isha.
Yeah, it's a pipeline.
It's a pipe separator over here, right?
Yeah, pipe it.
It's a text file mostly. Okay, no, it's not a CSV directly. So now how to read this? But we can treat it in a similar way like we used to do CSV. So using pd.read CSV, but with certain other parameters also. So there is no header here if you see, right? So header has to be marked as none. Then separator has to be marked as pipe, and this encoding has to be passed to read the text properly. So this is for English language. ISO 88591. So suppose if you read some different language, this encoding might change. Okay. After do this and then look at the head as well as the shape. So it should be 1682 of 24. Let me know once you're done till step 4. You have seen the head and you have seen the shape also of movies. Cool. Yes, quickly others also. Okay. So now if you look into the data, so there are no column names. So some 1, 2, 3 number is there, the name, movie name of the movie. Some values are there. So I want to make it more readable, right? So I'll add column names to this. Okay. So it's pretty long list. I'll just ping you the code so that you can just copy paste it. So we're going to use movie.columns and passing a list to that. Okay. So before executing that one, if I print movies dot columns, sorry, I get this, but I want names. So I'm assigning a list to this. Okay. And now if you do the shape, it is same thing. But now if you do the head again, movies dot head. Now we have a better way of showing the data. Yes, done. Okay. And now we don't want to use this release date, video release date, ID, and IMDb. The URL IMDb URL. So we want to delete these columns. ID. I want to keep title. I want to remove ID, release date, video release date, and IMDb because that's of no use to me. So removed ID, release date. This is gone. This is gone. Okay. This could have done like this also. That's totally fine. You can use multiple ways. And now we have this. Done. And make sure you do the check the shape again. So now it is 20 variables only, not 24. So now you should have realized that there is no y here. We have only features. We don't have any dependent variable here. Right. So now let's look at the data set line. Look at Toy Story now. So Toy Story is classified in animation, children, comedy. Three genres, right? GoldenEye is in action, adventure, thriller. Forums is in thriller only, and so on and so forth. Right? Now, there is one thing that we should do for each and every data set, but we've not done before, is checking for duplicacy. Okay, means there can be certain duplicate entries in your data set. So had I not removed the ID column, I would have never seen that. Right. So so this is just a hygiene check that you should always do. So we have this movies dot drop duplicates in place is equal to true. So now in place equal to true means it will update the movies data frame only. It will not create a copy of that. So we don't have to save it anywhere. See this, if I run this movies dot duplicated, false, 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 1653 is true. right? And if you want to sorry, it's not where is that? Now I want to just subset them. Movies dot title. Yes. Yeah, perfect. So now these are the duplicated movies which have more than one entries. Movies title, movies dot duplicated. Okay. Or other approach would have been you would have simply put, look at this, movies, sorry. Yeah, movies dot क्या है? Movies dot title dot yeah. See this. So those who are two are duplicated movies, right? Which has a frequency of more than one. Now it's pretty easy to drop them. Simply do this. X करो. Movies dot drop duplicates in place is equal to true, and then look at the shape. So now rather than having 1682, we have 1664 only. Okay. Let me know once you're done till 22nd. Yes, done. Isha, Upendra, Arvind, Ankit, Sandeep. Okay. Now do this. Find the count of movies with romance as one of the genres. So in how many movies do we have romance value as 1? I want the answer from your side. Since you're already an expert in pandas now. Tell me this quickly.
Do corporate education is the business leadership. Quantum computers and AI.
Yes. What is the answer now? Very good. I got 3 correct answers. Isha, Mohit, and Aman. Upendra, Sandeep, do this quickly. Excellent, Ankit. Yes, Upendra, quickly, please. Okay, see this now. Pretty straightforward. Movies romance is equal to 1. Save it in is romance. So what will be is romance now? It will be a logical vector. And then what I will do? I will subset movies with is romance and then count the title. That's it. So I'll have 244. Or easier way is this one. Movies romance value count. So I have 244 ones and 1420 zeros. So I have 244 movies which has romance. Clear? Finish till 24 quickly. Okay, done. Now do this yourself and give me the answer quickly. And I want to answer from all of you. From the count of movies with both action and drama as their genres. So action should also be one, drama should also be one. Do this now, very quickly. Aman, it cannot be more than romance is equal to 1, right? So earlier when romance was on, we had 244 movies, then how can action and sorry, it's action and drama, sorry. But the answer is not correct. It should be 46. Okay, let's see this now. Upendra, are you able to do this or not? Okay, see this now. Again, multiple ways of doing it. Let's see all the ways. One is I am separating and creating two logical vector is action and is drama. and then I'm subsetting movies using the AND operator when both of them are 1, and then counting it, so I get a 46. Other ways like which I prefer is group by. So group by action drama, and then you can count anything, maybe drama, maybe title, anything. Yeah. So now you have to see 1 and 1, that is 46. Okay. So finish till 26 quickly and let me know. Yes, done everyone. Okay, now let's come back to hierarchical clustering now. So it says let us first use hierarchical clustering to cluster the movies in the movie lens dataset by genre. Okay. After we make our cluster, we'll see how they can be used to make recommendations. And there are two steps to hierarchical clustering. The first step is we have to compute the pairwise distances between all the data points. And second, we need to cluster the points. Right? So these are the two steps that we have to follow. Yeah. Now to compute the distance, we can use the pdist function. That is pairwise distance. But we only want to cluster our movies on the genre variable, not the title variable. We cannot use the title, right? See this. I'll just go back. Yeah. If I have to find the distance between Toy Story and GoldenEye, I'll use this 19 values to find the distance. But I cannot use this title name, right? So I have to subtract from 1 to last 20. Okay. So it's pretty simple. Dist is equal to pdist. Now look at this movies.ilog. So I hope in Pandas you would have studied what is ilog. So it is used to subset without using the names of the variables. So I want to use 1 to 20. And then the Euclidean distance is what I want to measure. Let's do this now. Now print this. You'll get the pairwise distance.
Himanshu, from which library we get this function, pdist?
SciPy. I'll show you again. SciPy dot spatial dot distance. Yeah. Sorry, I'll just show you that back. Done. So this is an array, normal array with okay. Now do this. This dot min, this dot max, length of disk, and this dot standard deviation. So the minimum value is 0 between two movies. The maximum value is 3.16 between two movies. The length of disk is an array is this. Okay. I will tell you how this value comes, and this is the standard deviation 0.57. Yes, done. So the pairwise distance is computed. Now what we have to do, we have to create the clusters. So now we can use using the hclust method. Okay. It takes the affinity and linkage as arguments. We use the ward linkage. Okay. Now what is this ward method? So ward method is like your ANOVA. So I want to make a cluster which has clusters in such a way that I have high between group variance but less within group variance. Means within my cluster the movie should be homogeneous, but the distance should be between the clusters should be high. Right? So that's what ward does it for you. So now do this. So hclust is nothing but agglomerative clustering in Python. And see this now. So I already got hclust, so I've imported agglomerative clustering as hclust. This line. I'll just copy these four. Ideally, they should be there only. Yes. Okay. So now hclust pass the affinity is Euclidean, linkage as word and n clusters as 10. So now if you see, I will not be using dist directly anywhere as such because this will automatically do that for you. So this is just so we created a model over here. I'll explain you that. Here I have passed number of clusters as 10. So usually that has to be done after looking at the dendrogram, but this requires some value, so we have started with 10. I'll come back to you again, come back to this again. And now I'll fit the data. Model dot fit movies ilog 1 to 20. Right. So now the number of clusters are 10. And now look at model dot labels. Okay. And print at least 10. So now what are these labels? Yes, Isha. What are these model dot labels?
Yeah, I mean it's showing that in one cluster we have 6 observations.
No, it's like the first movie is in sixth cluster, second movie is in third cluster, third movie is
Okay.
in seventh cluster, fourth movie is in zero, that is first cluster, and so on. So this 10 is just a number that I've shown to, so you can put it 50 also. So these are the cluster allocation of the first 50 movies, right?
Okay.
Yes, done. Now just look at the unique labels and see the count so that I know how many how many movies are in each cluster. Okay. So this is the size of each cluster. Okay. Finish till 38 quickly. So now to plot the dendrogram, we cannot use this model scikit-learn. We have to use SciPy only. So in SciPy also we have the ward. So I'll again apply the ward on the movies. So I'm doing the clustering again using the SciPy library rather than the scikit-learn. And then I can plot it using this matplotlib. So x equal to dendrogram of z. This won't work on your model, scikit-learn model. So that's why I have to do these 2 steps. Do this. If you have any doubts, please ask.
Yeah, Himanshu, can you explain this 39 line number?
Sure. So now, Isha, so to plot the dendrogram now, so I cannot use this scikit-learn. So there is no method in scikit-learn to plot the dendrogram, right? So what I have to do, I have to use this SciPy library.
Okay.
So in SciPy, what I have to do again, I have to find the distances and then I have to do the clustering, right? And that too using this word linkage. So this is like your ANOVA. Okay. So what are the possibilities usually we have? I'll show you that also. Just a second. SciPy dot. Okay, it's actually नहीं अभी हो गया नहीं तो. Where is that gone? SciPy dot cluster dot hierarchy. Dot hierarchy dot. So these are the various methods: complete, centroid, dendrogram, distance, all those things. So out of these, we are using the word method. Okay, so that will compute the pairwise distance and then it will apply the hierarchical clustering also. Okay, now look at the shape of Z. शेप चलता है क्या इसमें? Yeah, 1663:4. So what are these things? To know that you can use the help of word. Performs word linkage on a condensed distance matrix. Or performs word linkage on the observation matrix X using the Euclidean distance as the distance matrix. So we are using the second thing. Okay. It returns Z, which is an ND array. The hierarchical clustering encoded as a linkage matrix. Let me check what all four things it returns. See, what are these 4 values? It is mentioned over here. A 4 by n minus 1 matrix that is written at the ith iteration. Clusters with index zi, 0 and zi, 1 are combined to form cluster n plus I. A cluster with an index less than n corresponds to one of the n original observations. The distance between clusters zi, 0 and I, 1 is given by zi, 2. The fourth value, that is zi, 3, represents the number of original observations in the newly formed cluster. So let's try to understand this. Just a second. I have to read it again. Just a second. So it says the indices I, 0 and I, 1 are combined to form the cluster. So just a second. Where is my code? Yeah. Okay. So the observation numbers first, that is 0, and observation number 418 are used to create a cluster 0. So these are all in the first clusters only. So if I just focus on the third column, this is, and let's say I put 100 values. So it's all 0 only. And let's say I print 200 values. Let's say I put 1000 values. So after some time it should start being, it's again 0 only. Yes. And let me just confirm. This is 0, 1, I0, I1, I2, I3. I3 में क्या है? The number of original observations in the newly formed cluster. So it is 2, 2, 2, 2, 2, 2, 2, 2, 2. Oh, give me some time. Let me revert back in the next class, like what are these values directly. But as of now, let's quickly compute the dendrogram using this code. Yes, do this quickly. Yes, done. Do this now. Meanwhile, let me check one more thing. Okay, see this now. So, you know what is a dendrogram, right? So at the bottom we have all the observations now, and then we have this clusters. So now if I cut it from here, I will have 2 clusters. If I cut it from here, I will have 3 clusters, right? And this vertical distance shows that yes, my clusters are pretty much far off. So 3 clusters is a good solution for this case. But if I use 3, I will have only 3 possibilities of movie recommendation, only 3 groups. So I want more number of clusters. So if I cut it from here, below 15, so I have 1, 2, 3, 4, 5, 6 clusters. Okay. So if I cut it from here, I'll have 1, 2, 3, 4. So I want 10 clusters, let's say. So if I cut it from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, slightly above. 1, 2. Yes, somewhere here I have to cut it to get the 10 clusters. So ideally, here now 3 clusters would have been good, but 3 clusters will not allow me to show some diversity of the recommendations, right? So we use dendrograms as a way of identifying the number of clusters, but then business problems can also, or the client can also tell you how many clusters he wants. Okay. Now do this. In the movies data frame, create a one more column clusters and assign model dot labels. And now look at movies. Okay. So now we have one more column clusters which has these values of the clusters 6, 3, 7, 0, 4 and so on. Finish till 54 and let me know quickly. Yes, done. Just a second. Okay. Good. Let me just go through the slides quickly. So we have seen this. We have seen the dendrogram. So we decided on. So we added this. Okay. So now we have done with the clustering process, and we have already assigned to each movie to one of the clusters from 0 to 9, right? But now I want to have a understanding like how the clusters look like, right? Means what kind of movies are in which cluster. So now how to do that? So now within each cluster, if I could find what all counts I have. So for example, other than just a second, I'll show you this. No, this will not work, sorry. So what I want to do is, let's say action, and then I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right now, so these are my movies up to 1664. Now I might have action in some 0, 1, 0 like this, right? So now I want to understand in each cluster how many action movies are there. Okay, let's say. So I think before doing so, let's do this. Just a second. Okay, tell me this, find out how many action movies we have in each cluster. Find that out quickly. Do this, let me open that also. Yes, please. Yes, anyone? Isha? I want to find out the action movies in each cluster. Can you tell me that? See this. Clusters. We have. See this. Okay. So I have 28 movies in each action n cluster of 0. Look at cluster number 1. Not a single action movie. So it's a pure cluster where there is no action, right? Similarly, look at cluster number 2, 30, 116. So 116 movies are there in cluster number 2. Then we have in third, we have 49, then 14, then 21, and so on. Right? So this gives me some indication of like what kind of movies are in action movies. Movies are in each cluster. This was for action. So say for example, now I want to do for romance also. See this now. So in last cluster there is no romantic movies. Similarly in second, third also there is no romantic movies. Right? But now I want to repeat this for each and every variable. And I don't want the just the romance variable. I want all the variables. Right? And I want the proportions, like what proportion of action movie, romantic movies are in cluster number 0. Now the benefit in this particular case is I have 0 and a 1 only. So if I take the, for cluster 1, I have 343 plus 90 movies. Right, try to understand this now. Look at this. So the proportion of romance will be simply 90 upon 343 plus 90, which is 90 upon, I think, 433. Right? The proportion of romance in cluster number 1. But now the same thing can also be computed by simply taking the mean of romance variable. So romance has values 0, 0, 0 and on some few ones. So how many zeros? 343. How many ones? 90. So if I take the mean, the sum will be again 0 is 90 only upon 423. Sorry, 433. So in this particular case, calculating the mean or calculating the proportional frequency, proportion is one and the same thing. It tells me what proportion of movies are there in that particular cluster. So that's why I have done mean over here. So in cluster number 0, there is no unknown. Okay, 92% is comedy. So it doesn't imply that, so the addition of these values will not be 1. So when I say 0.92, it means that out of all the movies in cluster 0, 92% movies have comedy as 1, 8% has 0. Right? 21% is drama, 20% is romance, and this is very less. Right? So what I can say that in cluster number 0, I have most of the comedy movies and drama movies together. Mostly the comedy. Right? So if I just take the top three genres, it should be comedy, it should be drama, and then it should be romance. Comedy, drama, romance. Right? That's for my cluster number 1. Let's make it somewhere. Let's open a Excel. नहीं समझ में आना तो just let me know. Okay. So cluster genre genre 1, genre 2, and genre 3. So cluster number 0 we have comedy, drama, and romance. How about the second cluster now? Look at this. 0, 0, 0, 0, pretty pure. 9% ignore. 0. 41% documentaries. 58% horror movies. Okay. So third one I would say take is 9% is thriller. And 9% is comedy also. So majority is horror and documentary. Horror, documentary, to some extent comedy, and to some extent thriller. Okay. Let's put it genre 4 also if in case. Now look at the next one. Now Isha, tell me. How about the third cluster 2? What kind of movies do we have here?
Mostly this action,
Action is there, then we have
drama,
slightly drama, and then we have this also. Sci-fi
thriller.
thriller. How about adventure? Adventure is not
Very
there.
less.
Very less. So action. Then what is the second highest?
Drama,
No, drama is 21 only, no?
okay.
We have
No,
38, 36.
thriller.
Thriller and sci-fi.
Then
Thriller, sci-fi, and then drama, right? Mohit, how about third one? %51% is action, 96% is adventure, right? So adventure, action, then children, right? And then 10% is drama, 27% is this sci-fi. So adventure, action, children, sci-fi movies, perfectly fine. Question number 4th, this one. Yes, Upendra.
Drama is 47%.
Mm-hmm. What is the highest?
So I can see in this, I think 47 drama is highest. Maybe if I go right,
No, but there's one more which is clearly, look at this.
oh, crime.
Crime is one, means all the movies have a crime of one. So crime to hai in movies, mein, right? So crime I will take drama, and then I will take 20% this action.
Action.
Crime is major, drama and then action. Yes. Fifth one. ये बताओ, श्रुति. Quickly, we have drama here. We have romance here. Yeah, that's it. Romance and drama. Comedy is no very less. Clear? Action I can take. Romance, drama and action. Let's finish this quickly. Sixth one. 0.03.02.40% this. Animation. 87% children. Children movies are usually animation. That's good thing. Yes, quickly. कोई रह गया क्या इसमें? Children comedy animation. Okay, seventh one. 0.30000016 less 31 14. Yes, बताइए. ईशा ये बताइए. Seventh वाला.
Mystery is 35, no?
Okay,
Yeah,
mystery is
mystery
35. Drama is
35, 31, and
80 is also there. Let's look at this.
okay, thriller,
Thriller, then mystery, and then drama, right?
right?
Right. Thriller. Yeah, eighth one. Yeah, quickly.
59 is 59% is drama.
59% is drama. Okay, what else?
War.
Where is war? Okay, 1.
9, okay, mystery.
Right. War and then उसके अलावा कौन सा है?
I mean,
War
two
is the
values are
highest.
same for two. romance is 19 and one more is 19. The column in the left. Yes. Yes. Action is both values are same. 19.
Okay, so war is first, then drama, and then
You can take either romance or action.
let's say action. Okay, last one. Pretty pure, right?
Drama. Yeah, drama.
Excellent.
Complete.
That's it, nothing else. Right. So now looking at here, you should understand that okay, your clustering process has been homogeneous. Is it? So in cluster number 0, we have comedy, drama, and romance, which is pretty common, right? Together. Then horror, we have documentary and romance. Right? Done. So now you can see that most of the clusters have similar kind of genres. Means so comedy, drama, romance usually come together, right? Horror and documentary comes together. Action, thriller, sci-fi, drama is very popular genre. Same is adventure, action, children. Adventure and children are coming together. Then crime, drama, action, romance, drama, action, which are pretty common. Then children, animation, comedy. And then thriller, mystery, drama, and then war, drama, action. Okay. So this tells you the interpretation of your clusters. Clear? Upendra, Isha? Okay. Write down a homework. Find out which cluster the movie Men in Black belongs to. Find out the cluster of movie Men in Black. Number 1. Number 2 is display 10 other movies that belong to the same cluster as that of Men in Black. So this you have to do as homework. First is in which cluster Men in Black belongs, and second is display 10 other movies that belong to the same cluster as Men in Black. Any doubts, anyone? Hello.
Yeah, Himanshu, can you explain that word
Go ahead.
linkage similarly?
Sorry.
Word linkage. Sorry, yeah,
Word linkage.
word.
Yeah, sure. Yeah. So see, how do I create clusters, right, in Python or maybe in R also? So when I say clusters means I want to have similar things together. Right? So how what do I ensure similarity? So we use word. So word is like your ANOVA. Means it minimizes the within group variance and maximizes the between group variance. Getting it? So the maximum variance will be high, but within will be less. So within is less means it's a homogeneous cluster which is far off from other clusters. That's the benefit.
Okay, so meaning so we want two clusters to be as far as possible, and within the same cluster, it should be as close as possible.
Sorry, come again.
So it means minimizing the maximizing the means minimizing the within group variance, meaning means all the data points in the cluster should be as close as possible, but two clusters should be as far as possible.
I'm not getting you. Can you please repeat? So I'm trying to maximize the between group variance,
Yeah, got it.
right? And minimize the within group variance. The formula is mentioned on the SciPy thing.
Okay. And one more thing is, when we calculated a plist, then the length of this is like 1383616. So what exactly is the output of plist?
Sorry, vision PDIST.
Yeah.
Yeah. Okay. So we have 1664 observations, right? So I told you that we have to measure NC2 distances. So we have 1664 C2, which is n into n minus 1 upon 2. That is 1664 into 1663 divided by 2. Do this. You get the same exact same value. Clear?
Yes.
If you calculate, you will get the exact same value. One three eight six one six. Right? And that's the length of dist also. Yes, anything else, anyone? Okay, we'll stop now here and we'll resume tomorrow at 9:30. Okay. Yeah, thank you so much. See you tomorrow then.